in support of this great appeal of Pope Francis. Scientists have, from all over the world, have responded. 1,600 met to study all data available in terms of climate change, and they were attributed the Nobel Peace Prize, and they supported the encyclical letter in its extraordinary action of creation. The relationship between science and faith is certainly one which is crucial and which underlines the need of a responsibility of scientists in the field of climate change. This is the topic of Professor Antonello Passini, a physicist and an expert of complex systems, a researcher at CNR, and an expert on air pollution, as well as author of many publications on climate modeling. Over to you, Professor. Hello, can you hear me? Wonderful, thank you. Thank you for inviting me here on the part of Luca Fiorani and all organizers, Valentina. And hello to my friend and colleague who has just spoken. Yes, my role is that of saying what is the responsibility of scientists. I would like to take a very clear example here, because at this point in time, the responsibility of scientists is to get people to understand how serious the problem is and to ensure that there is a correct perception of these problems. So, if you allow me to share my screen, here it is. Professor, just to say one thing, everyone is invited to ask questions. There will be time for a second round, and we will be able to ask questions to our speakers. Forgive me, Professor. So, as agreed, I will speak in Italian, but my slides are in English, so this will make it easier for people who are following from abroad. So, contrasting climate change, what is the responsibility of scientists? First of all, science is one of our main activities in our brain, along with art and everything else, literature and so on. But it is particularly important because science allows us to have a correct perception of certain problems and that society today places before us. In particular, our future depends on the kind of decisions and actions that we adopt. Often there is no action because of a non-correct perception of risk. Here, for example, I would like to talk about two crises so far. COVID-19, which I would have liked to be with you, but I am at home because I'm in quarantine, because my son is affected by the virus, so this impacts on us directly, and climate change, which too has a direct impact on us, even though if many are not aware of it. So if we compare these two crises, one which is more acute at this point and one less, is very important because it can allow us to risk and then give us mitigating actions.
Now, with the correct perception of the risk, well, this is so it's difficult to have correct perception of the risk, and this is specifically true with the COVID-19, because if you have a look at this graph on the left-hand side, I put together these two graphs. So on your left-hand side, you have the deaths in Italy since February 23rd, when there was the first death due to COVID-19 until late June. So you can see the evolution of deaths. You can see this after some dozens of days. Then on the right-hand side, you have a different curve. It's the enhancing of the temperature historically observed since 2005 and in the modeling, it covers the period 2005 2300. So the evolution of the system is much slower here. So it's much more difficult for us to understand the severity of the problem. Now, the most fundamental thing to be said is that both problems have the same dynamics. Now, this difficulty of accepting the importance of the problem is that COVID-19 is a paradigmatic situation. Why? Because in the earliest days, when the number of deaths was low, and there were deaths in other regions of the world, before Italy was hit, many said this will be something a little bit more severe than flu, and we're able to manage it because figures were very low. But that very period, scientists, epidemiologists in that case, immediately said, well, the figures are very low now, but the evolution of the pandemic, if we do nothing to stop it, will be exponential. And the exponential is here in the earliest days of deaths. Then there was the lockdown, and after some 15 days, we've seen that the two curves separated from one another. And this, in this stage, the role of scientists was fundamental, as is the case of the other graph, because many say 1 degree increase of the world temperature is not that serious. It has already hit crops, but if we do nothing to stop this warming, and if we do nothing to stop greenhouse gases emissions, the red curve here shows how the temperature would be. So in 2100, we would have almost 5 degrees more than the pre-industrial world. So in both cases, there are nonlinear growths. Well, this is not exponential, luckily enough, but it's not linear, so it's heavy growths. So we have to be careful. We have to be careful to when we have to react and take actions, because both phenomena have inertia and delay times. So what does that mean? It means that where is the inertia of COVID? It resides in the fact that when we do something to stop infection, to stop the epidemics, results can be seen only after 10, 15 days. Why? Because there's a delay time which depends on the incubation time of the virus. So some 10 days ago, I was happy, but I can see the result 15 days later. So there was a lockdown. We're going to see what happens this time, but also for climate change, there's inertia. Why this inertia in such a system that is difficult to stop? It's the permanence of CO2, and it needs many centuries to be disposed of. When we reject CO2 in the atmosphere, we see the result later on. If we stop emissions of CO2, there's a need to stop them now in order to be able to see results in some 20 or 30 years. Now, of course, the two phenomena use different scales of time, but they seem to be very similar. Here I have an equation. I borrow it. It's very simple. It's risk equal to the hazard times vulnerability times exposure. It's used by civil protection organizations. In my last book, there's an article where I use this very simple equation to make a parallel between the possibility of acting we have now for coronavirus and the possibility of action we have to stop climate change. Let's focus on coronavirus. What is this hazard? The hazard of coronavirus. It's the strength of such a virus. We know that it's much more hazardous than simple influenza. It's much more contagious than Ebola and SARS, even though it might be less lethal, but it's something huge that is hitting us, not in an unexpected manner, I have to say, but we'll deal with this later on. But we are confronted with this, and on this factor, there's very little we can do because the virus is powerful, and we have to be very careful. As to vulnerability, what is the vulnerability? The vulnerability of our organism. Some people are aged and sick, others are young and healthy. So the first body is more vulnerable than the second. What can we do? Of course, we can do something if we have vaccine, reducing the vulnerability because it protects. We do not have the vaccine right now, so we can do nothing on this too. And finally, exposure. Well, exposure counts how much you're exposed to the contagion. And this is the only factor we can act on, wearing masks, face masks, with social distancing and with lockdown. But it's an emergency situation because we cannot act, we cannot have an action on the other factors. So we have a limited power to reduce the risk of the coronavirus. So let's move on to climate change and the impacts of extreme weather events on the territory. Here, hazard is due to the violence, the intensity and frequency of these weather events. Today, the climate science says that due to global warming, due to man-made activities, these phenomena are much more intense and sometimes much more frequent. So we can do something on this factor, because if we reduce global warming, or we can at least stop the hazard of these events. And again, vulnerability. Vulnerability is the vulnerability of our lands, of our territories. We can have more or less vulnerable lands. It's due to man-made development. Cities are more vulnerable because they've been built not following all the rules, because torrents have been closed, because deforestation has eliminated the branches and the roots of trees which can absorb. So we have to introduce ourselves in an harmony in the environment to make it less vulnerable, or not as vulnerable as it is. And in the end, exposure, it depends on where we are going to place our structures, our facilities, our homes, our people. And we can do this with the risk culture. If I want to be intelligent, if I think I'm intelligent, if I do not comply with the urban plan, well, I'm not intelligent, because in the end, my people will suffer from this exposure. So what is most beautiful is that in this case, I can act on the three factors. So I can act more strongly on the risk than in the case of the coronavirus. By way of conclusion, there are common causes for the coronavirus and for climate change. For example, if we deforestate a tropical country for intensive farming, you see in a forest and we're hitting the cause of CO2 released, but on the other hand, we will increase the spillover of the virus from animals to man, using intermediate matter that is in detergents. However, in any case, as I was saying, in order to reduce the urgent risk coming from COVID-19, our possible actions are very limited so far, and we only have a chance to act on factor E exposure. On the contrary, as to climate change, we can act on all factors, so because each factor's value strongly depends on our actions. And even if the inertia of the system, some decades in this case, to act rapidly, however, we can plan these actions until we're not in emergency, because of that non-linearity that's been mentioned by previous speakers quite often can bring about vicious circles and can get the temperature to rise even more. And at that time, we will not be able to do a lot. So, in short, scientists can help perceive and have correct perception of the climate crisis, and even if this crisis will be devastating, will be ubiquitous and hit everywhere, but we do have the tools in order to act and reduce the risk. So please, we have to act right now in concrete manners. This was published on The Economist. It's Earth fighting against climate change. But the coronavirus, but behind the scene there's climate change, which is a bigger opponent. But I want to use a final word of hope, because we've seen we can act more and better on climate change than on coronavirus. Why? Because we do have heavier guns to fight the climate change. And this is a quotation from a movie by Sergio Leone. When a man with a gun meets a man with a barrel, we have a barrel against climate change. So these are the references I would like to leave you with to better improve your knowledge. Of course, organizers will get my presentation, so it's available for you. You will receive it if you want. Let me just say that the equation was used in my last book. It's the equation of disasters. And now there's this article that is being printed where you find the same remarks I've shared with you. So should you like to deepen this matter, you may find this in the references. So we should like to thank Professor Passini for helping us understand the importance of focusing on the scientific issues in order to observe also from a social viewpoint and from the viewpoint of the future, what are the issues at stake that we are confronted with. So thank you for introducing COVID as an emblematic case, because we are all hit. We are all living it. And on March 27th, Pope Francis was alone in St. Peter's Square that was empty, and he was reminding us the meaning of what we were living at that time. So here, more than in any other scientific pamphlet, we realized that faced with the confinement, the lockdown, faced with the end of our liberty. Well, the strength of Pope Francis' message was much more powerful than any scientific pamphlet. So the importance of such a dialogue between science and faith in order to accompany, to be much more aware of the importance of turning to ecological conversion. So it is worthy, since we still have a few minutes, it is worth reading some of the words pronounced, uttered by the Pope in the square that was empty. And some of these words were very touching. For weeks, darkness has taken over our cities, our lives, filling in the emptiness, and everything seems to be paralyzed. It is felt in the air. We are all afraid, like the disciples of the gospel. We have been caught by surprise by furious storm, and we realize now that we're all in the same boat. We're all fragile, disoriented, but we're all important. We're called upon to go together. We're all in need of being reconforted with one another. Now, putting together scientific evidence and the commitment of scientists and responsibility of scientists, using such a social important reading can make the greatest effect in trying to convert ourselves to ecological conversion. So the relationship between faith and science lives within environmental ethics. And Miguel Pañao, assistant professor of Coimbra University, is an expert in environmental ethics and deepened the dichotomy of science and faith as a member of EcoOne. So he can explain us what are the pathways of an environmental conscience.
I'm going to share my presentation. But while I share, I would like to say a short word of appreciation to all the translators. I mean, you're heroes in this conference. So thank you so much. I will try to keep a certain rhythm so you may follow as well as others. So let me just share my screen. And I guess you can see my presentation, correct?
Yeah.
Okay, so let me begin by asking a question. And the question is, assuming the movement towards a new environmental awareness makes sense, what is the first thing we need to do? Humans changed the planet, and in 2000,